How is your preparation going for your exam?
Yes, sir. Going, sir. Preparing for past semester question papers like that.
Okay, okay.
Current assignment is over, sir. I can answer anything.
Okay,
Past 2 year question paper, I will preparing, sir.
okay, okay. Okay, so let us start.
Okay, sir.
A packed bed of solids with density 2 gram per centimeter cube occupies a depth of 120 centimeter in a cylindrical vessel of inside diameter 10 centimeter. The mass of
Okay,
solids in
sir.
the bed is 10 kilogram, and the mean diameter of the particles is 0.3 mm. Water flows upwards to the bed and we know the density and viscosity of water. So first, you have to calculate the voidage. So this is similar to a problem we did last class.
Okay, okay.
I'll just do it now.
Yes, sir.
Don't worry, because I'll also write the answer because whatever answer I got, I'll tell. I think more or less it's correct only.
Okay, sir.
You can just check once.
Okay, sir. Okay, sir.
Okay, so first question. So it's a packed bed of solids. Density is 2 gram per cc, which is same as if I
Okay, sir.
convert to SI unit, it's 2000 kilogram per meter cube. Height of the packed tower is 0.12 meter. Everything I'm writing in SI unit. Diameter
Okay,
of
sir.
the cylinder is 0.1 meter. Mass of the packing is 10 kilogram.
Mm.
Diameter of the particle is 0.3 millimeter. 20 to 10 to the
Okay,
power
sir.
minus 3 meter. And they are pouring water through it. And water, we know that the density is 1000 kg per meter cube. And the viscosity is, this is rho of water. Viscosity of water is 0.001 Pascal second SI unit.
Okay, sir.
Everything I'm writing the same. So first, they have asked you to calculate. They have given we have written all the details now. 120 centimeter is same as 1.2 meter. So it's 120 centimeter, right? So it is
Yes,
1.2
sir.
meter.
1.2
Yeah.
depth, 1.2 meter. Yeah.
Diameter is 10 centimeter, I think. So it's 0.1 meter.
Mm. Yes, sir.
Mass is 10 kilogram.
Correct.
Mean diameter of the particles is 0.3 mm. Okay. So we have to find the voidage first. So this is the
Okay, sir.
cylinder. It has got some packing inside.
Okay, sir.
Okay. So
Okay, sir.
first we'll find the volume of the cylinder.
Mm.
Volume of the cylinder is what, pi d square by 4 into h.
Okay, sir.
So what is it here? I into 1.1 square divided by 4 into h. H is 1.2
Okay,
meter
sir.
cube. This is the volume of the cylinder.
Okay, sir.
Next step is the volume of the packing material. What is the volume of the packing material? We know the mass, we know the
Okay, sir.
density.
Mm.
So mass by density will give the volume.
Volume. Yeah.
Mass is 10 kilogram. Density is 2000 kilogram per meter cube. That's 10 by 2000 meter cube. Therefore, if I'm asking you what is the volume fraction of the packing material, it is the volume of the packing material divided by the total volume.
Okay, sir.
this if you calculate, you get some value. But say this is x, some value x, okay.
Okay, sir.
So this is the volume of the packing, volume fraction of packing material. So if I have to do
Okay,
void
sir.
h, void h will be 1 minus x. Okay. So it will be
Okay,
1
sir.
minus by 2000 divided by pi into 0.1 square plus 4 into 1.6. So it comes to 1 minus 1 by pi into 0.6. So if you calculate this, you will get 0.47. That's what I got.
Okay, sir.
More or less shows that 0.47 is the answer. Anyway, you can check the calculation yourself. So this is the voidage. 0.4. I'll upload everything now. Okay, don't worry.
Okay, sir.
So that's the voidage of the packing at 0.47. So second question is calculate the superficial liquid velocity at which the pressure drop across the bed is 8260 Pascal. Report your answer in millimeter per second. You got this right. Voidage you got now.
What, sir?
This first part you understood now. How we got this.
Yes, sir. I can answer, sir. Okay, sir.
Okay. This is the answer. Let's writing it.
Why we subtract 1 minus the volume fraction of
Because we want, they are asking the
packing material?
voidage fraction. Voidage
Okay,
means
sir.
empty space.
Okay, sir.
So if
Empty space.
packing
Okay,
material is
I
some
understand, sir.
fraction, then empty space will be remaining of that, right?
Oh, okay, sir.
If the volume fraction of the packing material is say x,
Okay, sir.
okay. So whatever is in between this, that is the empty space now. That will be 1 minus x.
Okay.
That fraction will be 1 minus
Oh,
x. If this is x.
okay, okay, sir.
Like
Okay,
that.
sir. Okay.
That's why we did 1
Okay,
minus. Okay, the second question is calculate the superficial liquid velocity at which the pressure drop across the bed is 8260 Pascal. Report your answer in millimeter per second.
okay, sir.
So we know that delta P is 8260 Pascal. And if you remember sir's lecture, he talked about Argand equation, right?
Yes, sir. Again, question.
It is a combination of the
Superficial.
Bose carbonate plus the Burke-Plummer equation. Bose carbonate is flow Reynolds number, Burke-Plummer is turbulent flow, about 1000 Reynolds number.
Okay, sir.
So the two terms I'm writing delta P by L is equal to, and first write the formula. 50 mu.
50 maybe not.
So here's the other thing is that you see the problem.
Okay, sir.
The mean diameter of the particles you have given. So that means they're spherical particles.
Okay, sir.
Okay, we'll assume that they are spherical particles. So sphericity will be 1
Okay, sir.
for spherical particles. Okay. Because sphericity also comes in the Argand equation. No? So that we'll take it as
Yeah.
1 and we will ignore. So the
Okay,
Argand
sir.
equation just reduces to this.
Okay. It is square. Yeah, perfect.
So and this
Sir,
you
one
not
more doubt, sir.
yeah.
Sir, one more doubt, sir. In the
Yeah.
first question, they mentioned the flow through upwards, sir. Flow upwards through the bed. Is there any special attention to solve the problem, sir? It's normal problem, sir.
It's normal problem.
Normal problem. Okay,
Yeah.
okay.
Like
Okay,
this
sir.
is the packing and they are throwing some material to like this.
Okay,
Okay. That's
okay,
all.
sir. Okay. Okay.
This U naught is nothing but superficial velocity. This is what they asked us to find in the second question. Epsilon is the void fraction or the
Okay, sir.
voidage. Mu is the viscosity. dP is the diameter of the particle. Rho is the density of the particle. You know delta P is already given in the problem. Okay, it's given as 8260 Pascal. Pascal means SI unit. Length is also given 1.2 meter.
Sir.
Nu is given because it is water, it is just 0.001
Okay.
Pascal second.
Hmm.
Density is given 1000
Okay, sir.
kilograms per meter cube.
Okay, sir.
Because here, see, if you see, yeah, water flows upward and water density is same cube. Viscosity is this. So everything is given. And epsilon we just calculated now. In the first
Okay, sir.
question. Epsilon we calculated 0.47. dp is 0.3 millimeter, na? 0.3 to 10 to the power minus 3 meter. Yeah.
Validate.
Okay. So now you plug in all these values in the
Yeah.
Eigen equation. Okay. So if you plug in all the values, you get 8260 divided by 1.2 is equal to 150.
DP, yes, sir.
Yeah, I'm just plugging all the values. Okay.
Fine, 20 minutes. Okay, sir. Okay, sir.
This is the Kozeny carbon part of the Eigen equation. And this is the Berg Plummer part.
Yeah. Okay, sir. Okay, sir.
Epsilon cube, right? So it's 0.47 cube, sorry. You have all the values now. So basically, this is a quadratic equation. This
Okay.
is V naught square, this is V naught. So it's on the form A square plus BX plus C. Okay. This is a second order, this is the
Okay,
first order
sir.
part. So basically, this is a quadratic
Okay.
equation, but we will make an assumption here that it's a very low Reynolds number. Though they are not told anything about whether it is the laminar or turbulent, and we also don't know the velocity. We're going to calculate
Okay,
it now. So generally in packed beds, it is
Hmm.
generally unless it's very rare cases. It is always you take it as
Okay, sir.
laminar. Okay, because the particles are so small, right?
Okay.
Because of that, the Reynolds number becomes very small.
Okay, sir.
So generally it takes it
Very smart. Yeah.
take it as laminar. So this part you don't need to take one part one by part. Just focus on this part. Then we'll later verify also that why it is so. So if
Okay,
you
sir.
calculate this, it is just 6883 is equal to 4509277. So and they have asked you to calculate V naught in millimeter per second, right? So V naught I'm
Yes,
getting
sir.
as 1.5 into 10 to the power minus 3 meter per second or 1.5 millimeter per second.
Okay, sir.
Okay. Because I assume that it is
Millimeter. Okay.
only low Reynolds number and it is laminar and I'll ignore the B square part, I'll
Okay.
take only the B part. But you can take the B square part and do as quadratic equation, so it's up to you. But I'll justify why it is so.
Okay.
Why it is such a small value.
Hmm.
Okay, so second part is done, 2.5 millimeter
Okay.
per second. Third is that corresponding to these conditions, what is the actual
Okay, sir.
velocity of the fluid going through the pipe bed? So the actual velocity will be nothing but V naught by epsilon, right? We saw that in the previous class also. If V naught is superficial, epsilon is porosity. So V naught by porosity will be the so this you'll get a 3.2 millimeter per second. Epsilon is 0.43 in our case. Okay.
Okay, sir.
So this is the third question.
Hmm.
So again, like if you now get this third part, see this is the
Okay, sir.
what was the modeling or model of that equation? He assumed like this is the thing. Instead of packed beds, he assumed that there are many cylindrical
Okay, sir.
porous channels
Okay,
through
sir.
which the water flows. These are all solid. That's how he got the equation for the Ergun equation, right? And through these channels, it is 3.2 millimeter
Hmm.
per second. Superficially, it's like
Okay,
if
sir.
there were no such channels. The,
Hmm.
the whole diameter, if you had considered, would have
Okay,
been
sir.
1.5 millimeters per second. So now we are assuming these channels in our
Okay.
model.
Okay.
So 3.2 millimeter per second. Now let us
Okay.
calculate Reynolds number. Okay. Reynolds
Hmm.
number is
Okay.
3.2 millimeter per second means 3.2 10 to the minus 3.
Okay.
right? Density is what? This is Reynolds number is rho VD by mu now. V we know 3.2 10 to the power minus 3. Rho is 10 to the power 3. Diameter is also again very small, 0.38 10 to the power minus 3. 0.3
Yes, sir.
millimeter now. Divided by 0.001. So you will get Reynolds number as 0.96. So which
Okay,
is
sir.
less than 1. So it is justified
Okay,
that the
sir.
Reynolds number is very small. So that's why just
So
including this
0.00.
cosine carbon part is justified. So that's how you recheck it, okay?
Okay, sir.
We could have
Okay,
taken
got
this
it.
entire thing and solve it as quadratic also, but
Okay,
that's
sir.
more
Okay, sir.
cumbersome now. Like it's more time
Hmm.
consuming. So
Yeah.
instead you just take one part and you calculate the velocity, then you calculate the Reynolds number.
Okay.
If the Reynolds number is very small, then you just tell that yeah, this is true. Here had the Reynolds number come as say 1000, then you would have
Okay, sir.
understood that this is the wrong assumption. You cannot neglect this part. Then we would have had to solve the quadratic or we had to go to the
Oh,
Burke-Flemmer equation. So that is how we back calculate and check.
oh,
Okay.
okay.
Okay, so these are the first three answers.
Okay, okay.
Just make note. 0.47 is the velocity. Then 1.5 millimeter per second, 3.2 millimeter per second.
Clear, sir.
Okay. So yeah, now we go to 4
Okay,
questions.
sir.
5 minutes break. Okay. So
Okay,
5 minutes break. We'll do 4, 5, 6. Okay.
sir.
Yeah.
Okay, sir. Okay, sir. Okay, sir. Okay, we will continue. Okay, sir. I will after 5 minutes. Yes, sir. Okay,
Yeah, okay.
okay.
We
We
go to the
start,
next
sir.
question then. Yeah. These three I'm very
I did
confident
all the
because
calculation correct, sir. No error, sir.
no error, right? Okay.
No error, no error, sir.
This, yeah, because this process is correct. I'm confident about it.
Okay.
Now here is where it gets a bit tricky, okay. This
Hmm.
next part. So okay. A leaf filter
There
has
is
an area of
some disturbance in your voice, sir. There is some disturbance in your voice.
now
Speak some words, sir.
now is there any disturbance?
Uh, little bit disturbances, sir.
Shall I I'll disconnect and then reconnect with.
Okay, sir. Okay. Okay.
Now is it okay?
Yeah. Now okay, sir. Now okay.
So the fourth question is a leaf filter has an area of 1.73 meter square and
Okay,
operates
sir.
at a constant pressure drop of 300 kilopascals and
Share
produces the
your
following
screen, sir.
results.
Sir,
What
share
the-
your screen, sir.
yeah. Okay. A
Yeah.
leaf
Okay.
filter has an area of 1.73 meter square and operates at a constant pressure drop of 300 kilopascal and
Okay,
produces the
sir.
following results during a test of filtration. So time is
Hmm.
given and the volume of the filtrate is given.
Okay, sir.
Assuming the cake is incompressible. Incompressible
Okay.
means S value is equal to 0. And alpha is equal to
Okay.
alpha naught into delta p to the power s, right? So S value is 0. So evaluate the slope and intercept required for the calculation of specific cake resistance and the filter medium resistance.
Hmm.
Okay. If you go to first lecture, this was this equation, right?
Okay, sir.
T by V is equal to Kc V to the power V Kc V by 2 plus 1 by Q naught. This is for
Hmm.
constant
Okay,
pressure.
sir.
We did two for
Hmm.
two, right? One is constant pressure and one is constant rate, flow rate. So
Okay.
this is for constant pressure
Okay, sir.
filtration. This was the equation.
Okay, sir.
So the equation was T by V is equal to Kc V by 2 plus 1 by Q naught.
Okay, sir.
And Kc again, that's an expression for Kc and that is
Hmm.
an expression for Q naught, right?
Do not. Okay. Okay.
That's a big, I mean, that's an expression, right? Anyway, that is
Yeah.
important because we just have to find the intercept and the slope in this problem. So first, like
Hmm.
I'll write the table time, which is in minutes,
Okay, sir. You see
volume
alpha
flow
by
rate, which is,
S per liter.
yeah. So T at 5 is 0.19
Mm.
meter cube. At 10, it is 0.31 meter cube.
Okay, sir.
At 15, it is 0.41 meter cube.
Mm.
At 20, it is 0.49 meter cube. At 25, it is 0.56. At 30, it is 0.63. So since in this equation, in this
Okay, sir.
question, here they have asked evaluate the slope and intercept required for the calculation of specific cake resistance and filter
Mm.
medium resistance. Okay. So T
Okay,
is
sir.
given, V is given, and this equation is what? T by V is equal to Kc V by 2 plus 1 by Q naught. That means you have to
Okay.
plot T by V versus V.
Mm.
It's like in the form of Y is equal to mx plus C. So T by V, we will do it in terms of second by meter cube,
Okay, sir.
so that everything is in SI unit. Let us not
Mm.
keep meter, minute, let us keep second.
Okay, sir.
T by V will do second per meter cube. So this is like 5
Okay,
minutes
sir.
per 300 seconds. So 300 by
Okay.
0.19, 10 into 60, 600 by 0.31, like that we'll have to do.
Okay,
So
sir.
just note down the values, what I got.
Okay, sir.
I may be wrong. So
Okay, sir.
they have told evaluate the slope and intercept required for the calculation. For slope calculation, use 2-point form. So 2-point form is nothing like normal. Slope is like y2 minus 7 by x2 minus x1, like that only. So if we take, this is y-axis, this is x-axis. See, it's
Okay,
t
sir.
by v now. T by v, it's like in the form of y is equal to mx plus c.
Mm.
So c is the intercept,
Yeah.
which is nothing but 1 by q naught, and m is the
Okay, sir.
slope, which is kc by 2. Y is t by v,
Okay,
x
sir.
is v. So when you do the slope, like it will be just y2 minus y1 by x2 minus x1. So if we
Mm.
take the first 2 points, 1935.5 minus 1578.9 divided by 0.31 minus 1.19.
Okay, sir.
So I'm getting something like 2970.8. And now if you do the intercept, to calculate the intercept, you just have to apply this formula. Y is equal to slope
Okay.
into x plus c. C is the intercept.
Okay, sir.
So take any particular point here. Say I'm taking this point only, 1578.9. So
Okay.
1578.9 is equal to slope into, at 1578.9, the x is 0.19.
Okay, sir.
Slope into 0.19 plus c. And slope we
Mm.
already know it's 2970.8. So C will
Yeah.
be, I got 1014.4. Okay, and here they have asked, actually here they have asked two things, evaluate the slope and intercept. That's why I was confused.
Intercept.
Okay, and they have only one blank. So either you have to put slope or intercept. I suggest to put the value of slope, because
Mm.
again they have told now for slope calculation use 2-point form. So maybe put this value. But even better, see the next question I got very confused. Okay, I did try in my way, but I'm not sure it
Okay,
is
sir.
right or wrong. So to calculate the
Okay.
time required. So I'm coming back to 4. Okay. Calculate the time required to collect 1 meter cube of filtrate during filtration of the same slurry at a constant pressure drop of 400 kilopascal. Now the pressure
Okay,
drop is
sir.
not 300 kilopascal, it's 400 kilopascal. So I tried to
Mm.
solve it through Sir's lectures and all. Like I don't think Sir has covered this part that well. So I referred to this
Okay.
book. I'll share that book on Drive also. Don't worry.
Okay, sir.
I'll share that book on Drive.
Mm.
It's called Introduction to Particle. I found the same question. I was just randomly searching in the internet. I
Oh,
found it.
okay, okay.
Okay. This exact question was there. That's why I'm going to this book. Then your
Okay,
answer
sir.
will be correct now.
Yeah.
Yeah, see this question.
Yeah.
6.9. A leaf filter has an area of 1.73 meters
Same
square.
question.
Same question,
Yeah.
right?
Same question. Yes.
And
Yes.
the
Yes.
answer
Yes.
also they've given. It is 49.5 minutes. This is what they've asked you to
Mm.
calculate. So I'm giving you the answer.
Okay,
This is
sir.
the answer. You can write it down. 49.5 minutes
Okay,
for the
sir.
first part.
10.9 minutes. Okay.
49.5 minutes, but I'll tell you how they did it. So they have used a slightly different form of equations here. So they have used this equation. Like sir has not taught in that way. Wait 1 second, wait. This part they have used, this concept. See here. Sir has not done in
Oh,
this part now, RC5 and all he did not do.
see,
He did not do like this. He did Kc by 2 into V plus 1 by Q naught he did. Q naught was in terms of Rm. So I'm refer to equation 6.27. So like
Okay.
I also the solution manual that also I got in the net. So I'll tell you
Okay,
how
sir.
they did it and I'll also share both the sources. You can go
Okay,
through it
sir.
when you're free. Right now you know the answer, but you can know how they did it. This part. So that solution I'm sharing with you.
Okay, sir.
I'm not writing it down. I'll just read from the solution whatever they have done.
Mhm.
See 6.9 and leaf plus 1.73
Yeah.
meters square thing. So
Okay, sir.
first what they have done is that they have used this equation, which sir has not taught
Mm.
in class. 6.27 equation they have used. Again, the
Okay,
same
sir.
concept is funda is same. They have to plot T by V versus V.
Mm.
See, T by V versus V they have plotted.
5 minutes. Okay, okay.
And the
Yeah.
gradient they got was 2960. Intercept they got
Okay, sir.
1000. Like we got
1000.
what?
Okay.
We got 2970 and 1014.4.
Almost correct.
Yeah, but maybe you use their value because they are from the solution manual now.
Yeah.
Maybe you write this answer instead of my answer. This is more accurate.
Okay.
They have
Okay,
plotted
okay,
the
sir.
entire thing and then they have gone through a linear regression line and then they have got this, I think. So this will be more accurate. I did using the
Okay, sir.
2-point form. Okay, so
Okay.
then they substitute this equation in this particular thing. Okay,
Okay, sir.
T by V is equal to slope into V plus
Okay.
this into V equivalent.
Okay, sir.
This is the intercept. So basically, RC5 into, sorry, RC5 mu by 2a square into minus delta P is the slope, which they have found
Okay.
out here as
Mm.
2960. So this is
Okay.
what they have found.
Okay, sir.
And the other thing is the intercept. RC5 mu into V
Mm.
equivalent by this is intercept 1000.
Wonderful.
And in
Yeah.
the question, the area is given 1.73 meters square.
Mm.
Delta P for that
Okay.
in that figure is also given in that table, 300 kilopascal.
Okay, sir.
So
Okay,
this
sir.
denominator you know. So from here in the
Mm.
first question, you can find RC5 mu, right? Because A you know, delta P you know. So A
Yes,
square
sir.
also you know, 2A square delta P you know. You take it to the right hand side,
Mm.
you will get RC5 mu. Then
Okay,
this
sir.
whatever RC5 mu you get, you put it over here. Again A
Okay,
you know,
sir.
delta P you know. You can find V
Yeah.
equivalent.
Equivalent.
Okay.
Okay, sir.
So V equivalent is 0.169 and RC5 mu is equal to this.
Okay, sir.
So now you again plug this into this equation, this 6.27 equation. This value know, RC5 mu you know, right?
Yes,
V
sir.
equivalent you know. So this intercept you
Equivalent.
know. This thing also you know, but only delta P now is changed to 400 kilopascal.
Okay, sir.
The question is written right. This entire table was at
Mm.
300 kilopascal, but here it is at
Yes,
400
yes.
kilopascal.
400 kilopascal. Yeah.
Yeah. So just make that one change and remaining will all be same.
Okay,
And
sir.
then you will get this equation T by V is equal to whatever.
Mm.
And they've asked that for 1 meter cube volume correction, how much time it takes. So in this equation, 1 meter cube you have to collect. Okay, so V is equal to 1,
Okay, sir.
and so you have to calculate T,
Okay,
and
sir.
they have got
Okay,
it as
okay, okay.
49.5 minutes. So
Okay, sir.
I'll upload both these books. Okay, you go through it once. If you have any
Hmm.
doubt, you can call me or something.
Okay,
But
sir.
this is how you have to do it. Okay, like if you apply
Okay.
search formula and all, you can't do it. That's what I found. You're getting
Okay.
very large values and all. So I think what
Hmm.
this is solution manual, and even book itself the answer is given. So it's better
Yes,
to
sir.
follow them, right?
Yeah, correct,
So I'll
correct.
just upload both these two, and I'm also writing the answer 49.5. And the
O-
previous question you can put this gradient, I think 2960.
Okay, sir.
Then let's see what the answer is. Okay, go
Okay,
through the
sir.
solution, and if you have any doubt, you can ask me.
Okay,
So
sir.
4 and 5 also done. Now 6 we will go.
Okay, sir.
Immediately after the class, I will upload. Okay,
Okay, sir.
by half an hour, the YouTube video will also come out.
Okay.
So the sixth question is what? The bed of ion exchange beach 243.84 centimeter deep is to be backwashed with water to remove dirt. The particles have a density of 1.24 gram per centimeter cube and an average size of 1.1 millimeter. What is the minimum fluidization velocity using water, assuming density of water to be 1 gram per centimeter cube and viscosity to be 0.001 Pascal second? The beads are assumed to be spherical. That means sphericity is equal to 1. The porosity at incipient fluidization can be taken as 0.4. Report your answer in
Okay.
millimeter per second. So I'll write what all we know here. We know that packing column is 243.84 centimeter deep.
Okay, sir.
We know it is 1.24 gram per cc, the packing material.
Okay,
We
sir.
know average size is equal to 1.1 millimeter.
Okay, sir.
The particles and raw water is given 1000 kilogram per meter cube.
Okay, sir.
Viscosity of water is given 0.001 Pascal second. Sphericity is equal to 1 because it's a sphere particles. And porosity at incipient fluidization is equal to 0.4.
Okay, sir.
And they want you to find the minimum fluidization velocity. So to find the minimum
Okay,
fluidization
sir.
velocity, so this is the formula. Sarajan and Classi. Delta P
Yes,
by
sir.
L is equated to the delta P is equal to rho GH, right? But
Okay, sir.
here it will be rho into G into 1 minus epsilon because epsilon is the porosity of the
Okay,
porosity, right?
okay, sir.
So whatever solid is there, it will be only 1 minus epsilon. So delta P is equal to
Okay,
rho into 1 minus epsilon. Sorry, G into 1 minus epsilon to rho P minus rho into L.
okay,
So
sir.
delta P by L is equal to G into 1 minus epsilon into rho P minus rho.
Okay,
And
sir.
this you can fit into the Argand equation. Delta P by L is
Hmm.
the Argand equation, no? Left hand side.
Okay,
So
sir.
this equation you will get. You can refer to
Okay.
students bit 1. Anyway, I'll write the equation now. So basically what he's doing is he's saying that delta P is equal to rho P minus rho into GL into 1
Okay,
minus
sir.
epsilon.
Okay, sir.
Right?
Okay.
Rho P minus rho into, you can refer to the lecture also if you want.
Hmm.
So delta P by L into rho P minus rho into G into 1 minus epsilon is nothing but 1240 minus 1000. Sorry. Into 9.8. What is epsilon? 0.4 now. So 1 minus
Fine
zero
for
point 0.4
yeah.
is equal to 0.6. Okay, so delta P by L is equal to this. And as per Argand
Okay.
equation, delta P by L is equal to 150 mu 1 minus epsilon square superficial velocity u naught by epsilon cube dp square plus 1.75 1 minus epsilon rho u naught square by epsilon cube dp. Fine.
Okay, sir.
So delta P by L you will get as 2352. So if you plug in all the values, you will get this kind of equation.
Okay, sir.
U naught we don't know. We have to find the U naught. That is what is asked in
Okay,
the
sir.
question.
Minimum fluidation
Yes,
velocity.
yes,
Okay.
yes. And you have to calculate U naught. Okay. So again, as I
Okay, sir.
said that in such cases you can safely take this part, Kozani carbon part, because it's usually
Mhm.
laminar in the packed bed problems.
Okay, sir.
You can later back
Okay, sir.
calculate and check also. I already checked, so you don't have to check.
Mm.
So you just equate this part and this part. You forget this,
Okay, sir.
and you will get U
Okay,
naught.
okay.
2352 is equal to something into U naught. So U naught is like
Mm.
uh, 1 second. Yeah, I got U naught as 2.02 millimeters per second.
Okay, sir.
Okay.
Okay, sir.
You also got that?
1 minute, sir. I will check, sir. 1 minute.
Actually, this it will be 2352 into 0.6. Okay,
Okay, sir.
because I forgot to take 1 minus epsilon. Now you check.
What is the answer? 3.3?
Check. I got 2.02 into 25 minus.
2.02.
Yeah.
What?
Will you multiply by 0.6 here?
Where, sir?
Here. I just added now.
Oh, okay, 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 sir. Okay.
Because this 1 minus epsilon is also there, na? 1 minus epsilon I did not add
Ah,
here. 1 minus epsilon is
okay, sir.
0.6.
Okay, sir.
Now you check.
Okay, I will check. 1.12. 69727. This 0.0202.
Ah,
It is in meters, sir. We convert into millimeter. The answer will be 2.02. Yeah.
0.02, no? So
Yes, sir.
yeah,
Yes, sir.
that is from this formula only I got. We have neglected this part, okay? Second part we have neglected. We have taken only the
Okay, sir.
Kozani carbon part. And
Okay,
even if
sir.
you take the second part, it will be almost similar only. And anyway, if you
Mhm.
check it back, it also will be very small. So you can make this assumption.
Okay, sir.
So this is also, so all questions are done, right?
Yes, sir.
Only that 4 and 5 I will send you the book, okay? You just
Okay,
check
sir.
the book once and then I'm also
The
telling
fourth
you the
question
page number.
answer will be
Note down the
1,000, sir. The fourth question answer will be 1,000, sir, or what?
fourth
What is
question
the
answer.
range, sir? Yeah.
Actually, they have asked both, right? Evaluate the
Yes, sir.
slope and intercept, but they have given only one blank. I don't know why they have done like that.
Sir, just go to the practice problem. Just put some values and check the submit and submit the button.
Ah,
We will get answer, sir.
okay.
Like that we have to solve.
Oh, maybe slope will be the
Same,
answer. Just
same type
you do
of
both.
question asked in the practice problem, sir.
Okay, okay.
Just put some values, one or two, anything, and
Uh-huh.
click the submit.
Okay, okay.
They will show the answer. What will be the range? At
Okay,
least
okay.
what will
You
be
can.
the answer
Okay,
like that.
okay. Okay, okay.
Just submit, sir. We will see.
I'll do now.
Yes, sir. Yes, sir. For your reference.
Okay. I've never done that actually. This time I'm seeing.
Okay.
So as per the book, like they have asked
Mm.
students zero I'm putting.
Mhm.
Oh, slope they intercept they have asked separately, see.
Oh, separate. Oh,
But here they have asked both is the same. There's only
both in
one
the
blank.
same.
Yeah, yeah.
Oh, from so specific.
See
Okay,
this, both
okay.
are wrong. But how can they be wrong, man? Like this is like from the book only we are doing right.
Just seconds will vary, sir. All the data are same.
Hmm.
Only the 8 and 0.49.
See, we are solving from the book only now. Book itself they written 2,61,000.
Okay, sir. Maybe the leaf filter has an area of 1.73. That will vary, sir. Maybe.
Oh, here the values are different. See.
No, sir. Same value,
Oh,
sir.
same values.
Yes, sir.
Then I don't know, man.
Sir, put the slope value in 1000, sir, like that.
I put now. They have told now. See, they are telling slope is
Oh,
4566.6.
okay, 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 okay,
They
okay,
are telling
okay.
this 840, 854.1. I'm not sure. I don't think this is answer. I don't know.
Okay, okay, sir.
Let's see.
So, okay, sir. That's it.
Follow
Okay,
the
sir.
book, man. That's better because
Okay, sir. Okay, I will follow
yeah,
the book, sir.
yeah. Okay. Other
Okay,
questions,
sir.
I think we are right only.
Okay,
You
sir.
also
Okay.
calculate. I also calculate. We are right. That's 2.02
Yeah,
thing. The
yeah,
first three
that,
questions we
yeah,
are
right,
right
sir.
only. Yeah.
Yeah, correct, correct.
Yeah. Okay then, man. That's it. Thanks.
Okay, sir. Thanks,
Okay.
sir.
Bye.
Thanks for.
Yeah. Bye. Okay. We'll take a small break and then assemble. Just I'll give you a small problem now. Alpha is equal to alpha naught into delta p to the power s, where s is the compressibility coefficient. Varies between 0.2 to 0.8. For incompressible K, S is equal to 0. Okay, so I'll give you a question. Find relation between specific cake resistance, that is alpha, and filtration pressure. From following data, obtained from a series of experiments. Constant pressure filtration experiments. Okay, so delta P in kilopascal is P alpha value is 1.4, 1.8, 2.1, 2.7, 4, 5.6 into 10 to the power 11. Each of them is into 10 to the power 11 meters per kg. So this kind of problem, how you will solve? So you know that alpha is equal to alpha naught into delta P to the power s. Take log both sides. Log alpha is equal to log alpha naught plus s log delta P. Then you plot log alpha versus log delta P. This will give you the slope and the intercept. Okay. So you know this value delta P, you know alpha. So basically you plot log alpha versus log delta P. Draw the graph, fit the line, and calculate what expression we get. So approximately you should get alpha is equal to 2.75 into 10 to the power 8 delta P to the power 0.56. Okay. Okay, so there are some other questions, but like they are in British foot pound system, foot pound second system. So I'm not willing to go into all those notations. Basically, there are just two types of problems, okay? Constant pressure and constant rate. You can check all the derivations done by Sir and the various values, the intercept values, slope values, what is alpha, what is Km, etc. Those are like the basic features. Sir also taught about centrifugal, concentrate filtration as well as centrifugal filtration. Anyway, I think whatever you have done today is enough. Like, it'll help you solve the assignment, and if you have any doubt, you can just ask me. So I think that's it. Yeah, thanks.